All right, so they give us the graph of f prime here, and I hope we're kind of getting used to this now that we've done a whole bunch of problems, that they typically give you the derivative. Every once in a while, they'll give you the second derivative, but most of the time they give you f prime. And if you're already thinking, hey, this is going to come up at some point, then your instincts are good. This is going to be interpreting our graph here. We're given the first derivative. So it says the function f is differentiable. You're not looking at f, you're looking at f prime, right? So just be aware, they're talking about a function that is not this, right? Function f is differentiable from -6 to 5 and satisfies f of -2 equals 7. Our accumulation is going to start at -2, not 0. It doesn't start at 0. They can start it wherever they want, and they started it at -2. The graph of f prime, the derivative of f has a semicircle and some line segments. It's shown right there. All right, letter A. Find the values of f of -6 and f of 5. All right, so we're going to find f of -6, f of 5. You're going to start with 7. This is where they're starting you off. It's going to be 7 plus, and then your accumulation is going to begin at -2. So we want to go from -2 to -6. That's why we're trying to end up f prime of x dx. And this one's going to be the same thing. It's where you started plus your displacement or your accumulation of area. Again, starting at -2, they didn't start it at 0, so it's going to start at -2, and this one we want to go to 5. And so we're going to use that graph to get the areas to answer these questions. So this one, again, starting at 7, we want to accumulate from -2 to -6. So we're going backwards. So this triangle is going to give us a negative area. So we're going backwards. So minus 1/2 base times height. The base is 4 and the height is 2. Now you can stop right there, but I'm going to let you guys know we're going to need these answers later on in this problem. So I'm going to go ahead and simplify it down. This would be 7 minus 4, which would give you 3. But you can stop right there. You don't have to go any further. All right, and then this one, same thing. We're going to start with 7. This time we want to accumulate from -2 to 5. So we want this semicircle and the triangle. Semicircle is going to be negative because it's below the x-axis. We're going forward, so everything kind of makes sense now. So this is going to be minus that semicircle, 1/2 pi r squared, and the radius is 2. And then I want to add on this triangle at the end, 1/2 base times height. So the base is 3 and the height is 2. So the 1/2 and the 2 are going to cancel there. This will be 7 plus 3, which is 10. And then minus 2 pi. 2 squared would be 4, half of 4 is 2. So 10 minus 2 pi. But again, you can stop here. You do not have to simplify it down. I just did because I'm telling you, I've done this problem before. We're going to need these answers later on. And so I just went ahead and simplified it down. All right, letter B. On what intervals is f increasing? Justify your answer. This comes straight from your sticky note. And if you got stuck on part A, you can still get part B. Again, they don't necessarily go easiest to most difficult. I think B is definitely easier than A. So if you read part A, don't get intimidated and think that and like fall apart on the rest of it and think you can't do it. Keep on going. It's my pep talk for you there. All right, f is increasing where the derivative is positive. So this is our derivative graph. It is positive where it is above sea level. So that is from -6 to -2. And then also from 2 to 5. So we're going to say from -6 to -2, union from 2 to 5, because derivative is positive there. I like that part. That comes straight from your sticky note. And I think you're going to be doing a lot of stuff like that on your AP exam. To answer that question, I think you're going to do a lot of like writing things out like this, explaining. I think they're going to have you do like basically like essay writing. All right, letter C, find the absolute minimum. This is a candidates test. Your candidates are your endpoints and your critical points. So let me make a table of values for f. Endpoints are -6 and 5. Critical points are where the derivative equals 0. So here's our derivative graph. This equals 0 at -2, +2, and 5. 5 is already on the chart though. 5 is an endpoint and a critical point. Now, this is why I simplified those other answers. We already did f of -6, we have that one, and we already did f of 5. They already had us do these two. -6 gave us 3, and 5 gave us 10 minus 2 pi. So we have those from part A. That's what we got in part A for both of those. Now I'm gonna need to just do these two. Again, we're starting with 7, and then our accumulation begins at -2. So 7 plus integral -2 to -2, you didn't accumulate anything, that's gonna be nothing. So this is 7 plus 0, so it'll just be 7. And then same thing for 2. So it'll be 7 plus integral from -2 to +2 up here. So from -2 to +2, that's this semicircle. We said that was worth 2 pi. It's negative since it's below the x-axis. So this would be 7 minus 2 pi. Now they asked for the absolute minimum. So this one's 3, this one's 7. If you think of pi as being roughly 3, this would be roughly 7 minus 6, which would be 1. So this is like roughly 1. And then this would be roughly 10 minus 6, so like roughly 4, just estimating there. So the smallest one is this one. So our absolute minimum is 7 minus 2 pi. And if you estimate like that, don't write 1. That's not what it is. That's just like roughly so we can see which one is the smallest. Absolute minimum is 7 minus 2 pi at x equals 2. Again, write out the whole statement. Sometimes they ask you for the maximum or minimum. Sometimes they ask you where it's located. And sometimes they ask you for both. So if you just get in the habit of writing the whole statement every time, then you're never going to miss it and you're never going to have to worry about it. All right, and then letter D, for each of f double prime at -5 and f double prime at 3, either find it or state why it does not exist. All right, so first let's do -5. Now this is the derivative. This is f prime. So second derivative means the derivative of that, and derivative means slope. So we're trying to find the slopes at these 2 points. So here is -5. We just need the slope at that point. So it's the slope of this line segment, which is going down 2 over 4. And you could leave it like that, -2/4, but I'll go ahead and use that, -1/2 for that one. So again, derivative means slope. We just want the slope at that point. And then the other one's 3, which is right here. Now that's going to be does not exist. And you can write due to sharp edge, but they're going to want you to bring up the limits from the left and from the right. Like that's not going to get it. You're going to need to do the limits because they're going to be, pickier than that. All right, so limit as x approaches, what was it, 3 from the left, and then your format for how you write that, it's, the function, which is, this is f prime minus f prime of 3 over x minus 3. Setting up a slope, it's like subtracting your y values and subtracting your x values. That's that pattern of the derivative. We did a whole page of those where you, figure out what the function is and then do the derivative and then plug it in. What was, was that 3? We did that in unit 3. If you want to look back, we did like a whole page of them. Anyway, from the left, this slope is, what is that, going up 2 over 1. So that slope is 2. And then we're going to do the exact same thing from the right. So I'm just copying that again. This is just from the right. So from the right, that would be this line segment. That slope is negative. Looks like it's going down 2 over 2. So that slope is -1. So what we're showing is that these two slopes are different. It's a fancy way of saying the slope from the left is 2. The slope from the right is -1. And that's why you end up with a sharp edge there because the two slopes don't match up. When I went over this with first block, I wrote f double prime there instead of the difference quotient. Look back at it. I'm not 100% sure. I mean, like, it's not wrong technically, but I don't know 100% that they would accept that. That's why I re-recorded the video. I'm not sure if they would take that or not. So I just don't want you to do that. So don't do that. Actually, just write out the difference quotient. I mean, what I meant was the slope. I just wrote second derivative. But I looked back at the scoring guide and they had it this way. So I was like, I'll re-record that video and just be a little bit more particular about it. Want to be accurate for you. Oh, points. Let me tell you how many points all this was worth. It's ready to stop the recording and tell you what everything's worth here. All right, in part A, you get a point for using the initial condition. So if you wrote 7 plus nonsense, you got a point. Give yourself a point. If you wrote 7 plus anything, give yourself a point. And then it was a point for getting each answer. And again, you did not have to simplify them down. You could stop here. So 3 points for part A. Part B, I like this one. I hope you got both of these. You get a point for stating those intervals and then a point for the reason why. I feel like that's 2 really easy points to get. I hope you guys all got that. Part C, if you put 2 on your chart, you get a point. If you even identified 2 as a candidate, you get a point. So that's awesome. And then it's a point for the answer with justification. So the chart is the justification. So this point encompasses, everything on the chart and stating the answer. And then down here is a point for the -1/2 and then a point for this whole explanation, which I feel like was kind of tough and a lot to write out. So that was kind of a tough point. Let me make sure I got all on. 1, 2, 3, 4, 5, 6, 7, 8, 9.